This motion super FRQ is going to take you through some of the motion stuff you might have forgotten that we did a while ago. In this problem, I am allowed to use a calculator, and I'm also given a velocity function. When you have a calculator, what you want to do is, your first move is to put this into either Y1 or F1, depending on if you have an 84 or an Inspire. I'm also told our position at t equals 0 is 7. The way that you say that symbolically is x of 0 equals 7. So x is our function, 0 is our independent variable, and 7 is our position. Part A wants the acceleration of the particle at t equals 3. We know that acceleration is the derivative of velocity. And you have to say on your paper that you're going to take the derivative of velocity and plug in a 3. So you must show this on your paper. But then from that point on, since we have a calculator to use, you're going to let your calculator find that derivative and plug the 3 in. So you don't actually have to show the derivative. You just have to give that answer, 1.543. On an 84, you want to hit Math 8. On an Inspire, you hit Menu and go to that Calculus menu, and you'll see derivative right there. In this particular problem, it tells me that I must indicate units of measure. I know acceleration is given as meters per second squared, so I indicate that onto my answer. In part B, the question wants to know if the particle is speeding up or slowing down at t equals 3. To answer that question, I'm going to compare the signs of velocity and acceleration. So I go ahead and I find velocity at 3, acceleration at 3, and I just use my calculator to find these values. For this one, I simply just plug the 3 into the velocity function. For this one, I'm just pulling my answer from part A down. I can see 1 is positive and 1 is negative. So what that tells me, speed is decreasing because velocity at 3, acceleration at 3 have opposite signs. Make sure when you get a question like this that you give specific information about this problem as to why you're choosing a decreasing speed. If you just say speed is decreasing because velocity and acceleration have opposite signs without showing some sort of information about the problem, even a correct answer will not get you credit. In part C, I'm asked where the particle is at rest, and what we know is that just means that our velocity equals 0. So I start this by saying velocity equals 0 at, and then I use my calculator to find the zeros of that velocity function. I'm going to want to make sure that I set my interval from 0 to 5, so that I'm looking for just the part of the graph that I'm being told to look at. And what you're going to see is we cross the x-axis at 2 places, 0.957 and 3.734. Make sure that when you have decimal answers like these that you do go 3 places out. In part D, we're asked to write an expression with an integral that gives the position x of t. This is our end position formula. So I'm going to start with x of t equals, I'm going to pick some known position, and at the very beginning of the problem I was told that x of 0 equals 7, so I start with x of 0 plus, now my integral is going to follow what I have here for my limits, so the 0 is my lower limit, the t is my upper limit, and what belongs as my integrand is the derivative of position, which is velocity. But since x is used here and t is used here, I have to pick a different variable to be the variable in v, so I just picked y. So this is our end position formula. In part E, I'm asked to use that formula to find the position at 2. So I'm just plugging in a 2 in for my t's, which is my upper limit of that integral. So x of 2 equals x of 0 plus 0 to 2 of that velocity. And also, it's okay to start the problem by plugging that 7 in right away. So instead of calling it x of 0, you could just jump straight to the 7. So either one of these 2 equations is okay. And then you just plug that into your calculator to get your final position, either rounded or truncated. Part F is asking for total distance traveled. Whenever you have a total distance traveled problem, you must show that total distance traveled integral first, and then type it into your calculator to get your answer. Part G is asking for the displacement of the particle. I first must show my displacement integral, then I just type that into my calculator to get my answer. In part H, the question wants to know where is the speed of the particle equal to 1? And we know that speed is the absolute value of velocity, so that's our starting point. We then must take this one absolute value equation and write two equations for it. So to clear the absolute value, we know that v of t could equal 1, or v of t could equal -1. To solve these equations, or any equation on a calculator, you're going to put one side of the equation into y1, you can put the other side into y2, and then you just find the intersection point. It is easier to do if you set that interval, so set your window to go from 0 to 2, and then hit zoom fit, and it's going to maintain that x interval, but it's going to set your y interval to show you all the important parts of the graph. And then finding those intersection points gives us, the first one is 0.786, and then our second intersection point is 1.216. In part I, we're asked for the average velocity, and remember our interpretation of that is an average value of velocity. So I have to do an average value setup for this one. That is an integral over an interval. My interval is just going from 1 to 3, so that's 1 over 3 minus 1. If this is average value of velocity, then what belongs here in my integrand is velocity. Once you have this set up, you are just typing buttons in your calculator to get your answer. And you can either give this rounded answer -1.870 or the truncated answer of -1.869. The next question is asking for an average rate of change of v. So we use our average rate of change formula. If we're using our function v, what this is going to say is v of 5 minus v of 1 over 5 minus 1. And then we use our calculator to get these values, just plugging them into that original function. And when that's done, we get a final answer of 1.768. Our last question here is asking to explain the meaning of an integral. Whenever you explain the meaning of any integral, there are three components. Number one, you have to say what it represents. Number two, you have to use units on your answer. And number three, you have to say what the limits mean in the context of the problem. So first, the what. What is this? When I see the 1 over 6 minus 0, that is a telltale sign that this is the average of something. So this is an average of whatever is sitting right here as your integrand. When I see that absolute value of velocity, that represents the speed. So the what in this problem is average speed. The next part of my explanation is the units. I know that speed is measured in meters per second, so it's speed in meters per second. And my third component to my explanation is what the limits mean in the context of the problem, and that is just a time interval. So from t equals 0 seconds to t equals 6 seconds. And lastly, just a few reminders when you have calculator questions. You must show a setup along with the answer. So if you just have an answer without any sort of required work, then even a correct answer will not earn you credit. And what I mean by a setup is if you're going to use your calculator to evaluate an integral, to do a derivative, or to solve an equation, make sure that those items, the integral, the derivative, and the equation show up on your paper. And always, always, always remember to go 3 decimal places out. You may round or you may truncate, but you do not have to simplify. And lastly, make sure that you justify all answers. Even if the question doesn't explicitly say to justify, it's a good idea to do that.